All right, let's move on to one from section 1.4 real quick. Take a stab at one of these. Calculate the tangent of 15 pi over 4. Well, it helps for me to actually kind of get an idea of what that even means. 15 pi over 4 I struggle with. I know every 2 pi is a full revolution on the unit circle, but 15 pi over 4 may or may not mean a whole lot. So for some of you, you may want to take 15 pi over 4, and you may want to convert that to degrees by multiplying that by 180 over pi. So I'm going to multiply that by 180 over pi. And let me, real quick here, I don't have a calculator on me. I'm going to keep my annotations here and just pull up my calculator real quick. So 15 times 180 equals 2700 divided by 4. So it's 675 degrees. All right, so get back into here real quick and find there she is, 675 degrees. Again, just 180 times 15 became a big number with pi, divided by 4 pi. The pi's cancel out, and we divide by 4, and we get this 675 degrees. Now that might be enough to kind of tell you what you're looking at here. I'm going to kind of draw a graph here of where we start here. So now we know if we start at 0 right there, and we go one time around, that's going to be 360 degrees, right? If we go another time around, that's going to be 720 degrees. So let's go another time around. Right to there is 720. So 360 here, 720 here. And I'm trying to think, so yeah, so if you go back 45 degrees, 720, and then go back 45 degrees, you're actually at 675 degrees to get to here. So that's where we're at there, 675 degrees. I'm going to erase some of that real quick because we don't need all of that right now. All right, get rid of some of that mess there. So 675 degrees resides down in that quadrant down there. And I'm going to try to draw this again a little bit better this time, maybe. I'm going to give myself some better lines here. So we'll go down, and we'll go over X and Y. All right, so I know that I am right here at 45 degrees on the unit circle. This is the worst drawing of all time. Getting used to this guy here, so let's try this one more time. See if we can get a nice clean drawing here. All right, there we go. And pointer, pen. All right, so we'll go right here, and we'll go straight down. There we go. That's a nice one. And then we'll go over here, right about here, and we'll go straight across. There we go. I like that. There's your X and your Y. Your 45 degrees is actually going to come right down about like that. And we know that that's actually on the unit circle. So this hypotenuse is 1. And we do have a right triangle right there with hypotenuse 1. But this right here is actually 45 degrees. So I need to calculate these points here. And some of these points you'll eventually kind of just know. You'll be like, oh, that's right, I know what that is. One other thing I could maybe mention here is the tangent of any number, the tangent of any number theta, is actually equal to just y over x is all we're doing. So y over x. So all I need is the whatever this x coordinate is here, okay, and whatever this y coordinate is here, and they're going to be the same because it's 45 degrees. I just don't know what they are off the top of my head. I actually do, but I pretend for a second that I don't. So let's draw this right triangle that looks something like this. So there's your right triangle. There's your 45 degrees right there. Okay, and we know that this has a hypotenuse of 1. And we actually know that these are equal. These leg lengths are actually equal, even though my right triangle doesn't look that way. So if I can find any trigonometric function that'll give me the adjacent or the hypotenuse, so I could say sine of theta, sine of 45 degrees, is equal to the opposite, Okay, and this would be the opposite right here over the hypotenuse, which in our case is 1. So the sine of 45 degrees is equal to, essentially it's equal to the opposite. So now I'm going to go real quick out and find out what the sine of 45 degrees is. I'm going to keep my annotations here, and I'm going to go to the calculator, and I'm going to make sure I'm in degrees. I'm going to type in 45. I'm going to take the sine. It's 0.707. And if you're not sure what 0.707 is, there is actually a nice little point. It's actually root 2 divided by 2. You may not know that off the top of your head, but root 2 is, most of you know, is 1.414. So root 2 divided by 2 actually gives you the 0.707. Okay, so that's interesting. That actually helps us out a lot. So if I'm just looking at this guy right now, let me turn my slide back on there. So I'm actually looking at this guy right now. This side is actually 0.707, which is root 2 over 2. And this side is 0.707. And where we say that root 2 over 2 is approximately equal to 0.707. All right. All right, so the next thing I want to do is, I know that's actually both the sides. However, one thing to be careful of is this point here actually is a positive root 2 over 2. And this point here, this y term, is actually a negative. Let me fix that real quick. Pointers, eraser, there we go. I don't know why the dots don't erase, but that's okay. And pointer, pen. So it's a negative root 2 over 2. So if I want to rewrite this, I can say that the tangent of 675 degrees, or even better yet, the tangent of 15 pi over 4, which is 675 degrees, is equal to y over x. Well, y is negative root 2 over 2 over a positive root 2 over 2. And some of you might say, well, you know, I don't really want to leave a fraction over a fraction here. So anytime you have dividing two fractions, you can also multiply by the reciprocal. So this is equal to negative root 2 over 2 multiplied by the reciprocal of the denominator there, which would be 2 over root 2. So what's kind of interesting there is this becomes a negative 2 root 2 and a positive 2 root 2. So 2 root 2 over 2 root 2 is actually, well, I'll write it out, negative 2 root 2 over a positive 2 root 2 is actually equal to negative 1. And if you type that into your calculator real quick, I'll hit escape. Keep my annotations there, go back to my calculator, and it was 45 degrees. And I want the tangent of that. There's my tangent function. Oh, grabbed the wrong one there. Hold on a second here. Let's go back in here. Degrees. Oh, yeah, we got to be careful here. So really, we're not talking about a positive 45 degrees, are we? Positive 45 degrees would be this way. So we're really talking about a negative 45 degrees, which in our case really was 675 degrees. So 675 degrees tangent, there's your negative 1. Okay, that's what we're looking for there. So, and that was our answer right there. So that is 1.4, number 18.